Hey, hello everybody. I'm Rupa, and with me today is Jiri.
Hi.
Yeah, SwitchDev workshop. This workshop is not just the SwitchDev API, but we've been having this workshop since a long time, but under different names, Switch, ASIC offload, and so on. But it's about running Linux networking on switches and routers. And a bunch of us here, even in the audience, have been working on this since some time now. Today's agenda is this. I'll make myself useful and talk about a few updates. Uh, Not everybody follows NetDev, and many features do get implemented in this space. A lot of important work and intrusive work. Sometimes it appears on LWN, and sometimes it makes to some distributions. Otherwise, it's just hidden. So I'll take a few minutes to just quickly run down a few things that I have seen, at least on the NetDev, and I'm aware that it's getting deployed. Jiri is working on some important next generation stuff, which is supporting modular switches, right? Jiri, as you know, has been the SwitchDev maintainer, DevLink, and a lot of new things in SwitchDev. Marvel, Moti, we will get you backstage when your turn comes. And Marvel switched. They have been working on a SwitchDev driver, and it is part of the Dent project. So Marvel is Moti is going to share some updates. And then Alex is going to talk about some operational things that he's been working with SwitchDev and deploying SwitchDev. So Alex, you too will get you backstage when the time comes. Okay. And I cannot see the screen nor the chat. I'm hoping Shajit and Giri are watching. So many of the functions that were implemented recently are also talks. People are talking about it. Routing, in the routing area, there were the hash algorithm. We had a ongoing issue, not an issue, but a difference between how hardware has the multipath hash policy configurable, but not software. And in software, we have done a few changes in the past few years where we added another sysctl option for another hash variant, but Edo from Mellanox has actually, NVIDIA Mellanox, has actually made this configurable and aligned with the hardware. And I think during the course of this, many things were explored, even including eBPF using eBPF to set hash policy and so on. Resilient hashing. This was another major work by Edo, again from NVIDIA Mellanox, and there's a talk next week on it. This is the Linux kernel never had it, and the work includes offload and so on. Route hardware offload failed indication, wait for install. And this might have been talked about in the FRR workshop, but some customers do want to not advertise routes if they're not offloaded. So there's a recent update to the route offload flags in the kernel to indicate to control plane that a route offload has failed, so it can withdraw the route. Okay. Now, 802.180, that is QNQ MLXSW update for it went in recently. Packet sampling enhancements. Again, Edo from Mellanox has been working on this quite extensively. If you guys have seen the drop monitor enhancements, packet sampling enhancements, there is a talk on this too, how SFlow uses it to deploy, uses some of these features. And as you know, these are in the Linux kernel, so it's available to not only some SwitchDev-based systems, but all Linux kernels-based operating systems. Linux bridge updates, we have had quite a few bug fixes. Actually, the DSA drivers have been adding support for more offload features and offload. I think some of them were spoken about in the last NetDev as well. Marvel, I just happened to see some, but I have not been paying attention to NetDev quite a lot, but Moti is going to cover that. Sorry, I think I repeated one of them. So the link protodown reason. Another operational thing that usually comes up is, and most vendors have a way to actually keep a link down on a protocol or a control plane to keep a link down. So we had that feature, but we couldn't use it when multiple actors in the system are using or want to keep the link down. So a new additional thing to set a reason, and this helps in operationally in data centers for flapping links to keep them down, or a protocol wanting to keep a redundancy protocol wanting to keep a link down. DSA, unfortunately, there are a lot of updates, and the maintainers or the contributors could not join due to other conflicts. But hopefully, we'll have some updates in the next NetDev. Futures, routing active backup next hops. I'm sure David Ahan is in the crowd. And yeah, if you want any work, I'm sure David has it in his tree. So active backup next hops is one of them. I think the FRR workshop also talked about it. And this is something that will hopefully get merged soon, and we'll find more use cases. There are also other use cases for multiple active next hops, depending on other factors for choosing a particular ECMP group. So hopefully this will see more use cases in the future. Bridge and IGMP. For switches and routers in the media space, multicast is important, and IGMP, and most switch dev implementations use IGMP from the bridge driver. That's a default implementation. And Nikolai, I'm not sure if he's here, but he's one of the maintainers, and we've been making a lot of improvements to, bring things like S-G support, per VLAN IGMP support, which is in the works. And I think there was also a thing floating around about moving the IGMP, allowing Bridge to use to have an IGMP implementation in user space. I think that will be great. I mean, we have also been considering it. So Bridge already supports having, for example, it has an STP implementation and also supports an MSTP user space implementation. So I think we'll see more when these switches get deployed in the media and multicast space. So other usual operational stuff that keeps coming up is scale, because you're a switch or a router and you need to support multiple. There are always different use cases. For example, a service provider use case where you have multiple bridge domains with overlapping VLANs. And there is a limitation in the current VXLAN driver, which if you want to scale VXLANs with collect metadata. So these are patches in the works again. Hopefully we'll remove this limitation. They're just waiting to be posted upstream. So we'll be able to scale VXLAN with the single VXLAN device, and FRR, the routing stack, supports it already for EVPN and so on. So I think this will be one of the last major things in scaling net devices. That's all I had. Any questions so far? Otherwise, we'll move to the...
Rupa, there was a request to go into presentation mode, I guess, to make it a little bit bigger, but
a little too late.
Maybe after the fact.
Yes,
sorry about that. Any other questions? There is one question for Ahern.
Great.
When will you be done? Other than that, I'm not seeing.
Oh, when will he be done with
active backup next?
Active backup.
Okay, I don't see anything here. So, like I said in the chat, if you have questions, ask them in the Q&A tab, in the chat tab, or raise your hand, and we'll have to invite you in. But there's only one. Unfortunately, on the system, there's only one question mic. So if you raise your hand, we'll effectively walk the mic over to you. And that's the way you can be in an interactive question and answer session. David has a response. We can continue though.
Okay. So Jiri, you're on. You can share.
Okay. Oh, wait. Let me share the screen. Okay. Okay, so I will talk about module systems switch. Module switch system, which I'm currently working on, the support for that. And there might be multiple ones, but currently, as an example, there is a NVIDIA Mellanox SM4800 module switch platform, which is actually based on Spectrum 3 ASIC. And it is managed by MLX's W driver, which many of you know, I'm pretty sure. And it is connected over PCI. So in this system, there are 8 slots for line cards, and basically each slot is populated with 4 SerDeSes, and there are no built-in ports on the board. So that means that the switch only has 8 slots. So if the slots are empty, there is no port on the switch. So the line card here, let's just put the term in place. This is basically an adapter between SerDes and one or multiple SFP cages. And the line card types, which are currently supported, let's call it A, B, and C. So either you have the 1-to-1 SerDes port mapping with 400 gigabit ports, or you have 1-to-4 SerDes mapping for 16 100 gigabit ports, and that is actually done using something which is called gearbox. So you have 4 gearboxes, and each SerDes is connected to a single gearbox, and that basically breaks it to 4 ports. And the last type is C, and that actually have 8 200 gigabit ports with 1-to-2 mapping between SerDes and the port. Unfortunately, this particular platform doesn't have plug and play support. That means that whenever the line card is plugged into the slot, the firmware actually doesn't know about it, because it does know that something was plugged in, but it doesn't know the type of the line card. So it's a limitation of the hardware, basically. So here there is how to overcome this limitation is to support to provide something which is called provisioning. So the user have to say which slot is going to be used for which type of card later on. Okay, so what is needed from the DevLink perspective for this? So the first thing, which would be probably nice, is to be able to list the current provisioning. Then it is also good to expose some information about the line card and the gearboxes which are on it. You can have multiple gearboxes on a single line card, like a firmware version, etc. It would be also good to provide provisioning and unprovisioning for the slot, as I said earlier, because of the limitation of the hardware. And also this is something specific to the MLXSW, but it has to react on the activation event, which is actually triggered outside the MLXSW. And last thing, which is needed as well, to burn the firmware on the particular gearbox. So let me walk this through. Here there is an example how you can see on our example system when you do devlink LC show, which is something which is proposed. It is not currently existing, but this is proposed API. You can see there is a PCI device, the devlink handle. Oh, wait a second. Okay, and you can actually see 8 line cards which are numbered from 1 to 8. There is a state for each of the line cards, so this particular one has active state. There is a type which is 4 times 400G. You can actually see the supported types for each individual line card, and for the line cards which are which contain gearboxes, you can see the gearboxes under the name of device. So here, line card 5 is the only one which actually contains gearboxes, and you can see there are 4 of them. The first one is flashable, and the name of the component is LC5_dev0. This is actually something which you have to remember, because on the last slide, when I will show the example of the flashing of the gearbox, this is the component name which is going to be used in the example. Okay, so if you do -v, you will get more information about the line card. So here I'm just typing in the show command for the line card number 5, and you can see there are some versions of the hardware and INI, and also you have some more information about the running firmware version of the gearboxes, of the devices / gearboxes. You can see that all of the gearboxes are running the same version because they are actually sharing the same flash. Only the first one is flashable. The second one, the third one, and the fourth one are using the same flash as the first one. Okay, so this is very simple example how to set some slot provisioning. So here I just set the line card 3 slot with type 16 100G ports, and the second command is going to unset it to no type, which will basically make it empty, the slot. And the last example is the gearbox flashing, and here there is the proposal is to use existing devlink flash command. So the only change which is different from the ordinary flashing of the device itself is that you provide the component name, as I ask you to remember the name. This is LC5_dev0. And that means that that the gearbox on LC5 is going to be flashed. Okay, that's about it, and I'm expecting some questions.
Not seeing any. There's one.
Oh, yeah. So the question is, okay, I see the question. So the problem is that sometimes the BMC is a different CPU, so and sometimes it is not actually, and also it is a different, like you have to know the type inside the driver, and there's no really easy way to get the type to the driver, as far as I can tell.
If that's the only, there are other problems that comes with it, and I'm assuming you have to also set up the Spectrum 3 the right way. But you could do what you're calling configuration, pre-configure the templates, and then pick from that based on the I2C inputs, right? That would be one way you could do that.
You mean have profiles?
Yeah, and then select, right? I mean, have a polar that's, or a daemon that is looking at I2C input, and then based on the input type, you go and say, okay, this is what I just got. And
basically from user space, auto provision from user space.
I mean, eventually I'm assuming the hardware will fix itself.
Yeah.
The old Jiri would have said, what's with this broken hardware?
Well, the idea is to basically have eventually some user space daemon, like, I don't know, something which is part of systemd maybe, which is looking at things and doing the provisioning accordingly. And also another thing is that the provisioning is needed anyway, because sometimes you just want to have the ports and net device and everything configured before you actually have the line card plugin. And also there might be a mix-up when you plug different type of the card to something which is configured already. So so it is handy one way or another to have the provisioning in. And also it is consistent with the way we treat the cable splitter. So when you have a SFP case and the splitter cable is plugged in, you also don't you do the provisioning in before you actually do plug in the splitter cable. So you say devlink split port count 4, for example, and the ports are going to appear, networks are going to appear as well. So this is similar to that. It's also basically provisioning.
Can UDEV be extended to, Shri? You talked about systemd, UDEV-D, maybe?
Yeah, but it's actually a very good question. I am currently looking at the option to support events from devlink and do some action devlink related to that. And so far, I don't see an easy way to extend the UDEV to support devlink, because UDEV is based on the sysfs and the EU events, and in devlink we have multiple objects for one device, so there would have to be some tree of sub devices, and that's going to be messy. So that's one option. Another option is to have like a separate infrastructure for the events for UDEV for devlink, and I don't think it's a good idea to do it that way either. So maybe the best solution would be just to have a separate daemon, like you have currently UDEV-D, you have network-D, which is taking care of configuration of the network. So maybe we can have a devlink-D, which would just open the netlink socket of the devlink and I don't know.
Yeah, well, I mean, I think that's a requirement actually, right? So if you think of the operational part, right, the person who changes the cable is very unlikely to be the person who has the operational console, which often creates this issue that if you change the cable and you require somebody to type some commands, it may not be there may not be a linkage. So actually, I think there are some questions to this point. So maybe somebody, Taras says, is network configuration stored in the driver and applied once the card is provisioned? And before you go there, because it sounds like it's similar, Ahern says that.
Andrew has a point before that, I guess.
Yeah, well, regarding the question provision and pray, I'm not sure about the praying, because when you provision some slot with a type X and you insert card Y, it's not going to be activated. Like the activation of the line cards only happen when there is a match. So
there is a follow-up to that.
Yeah, this was the follow-up from Andrew. I can just
yeah, well, as I said, I think that it is good to have some consistency in the provisioning model, and this approach is consistent with the splitter cable. Also, we can provide possibility to do the plug and play support for the splitter cable. It's actually our hardware supported. There is just we just have to extend the infrastructure a little bit to support it in Linux. So perhaps we can this plug and play certainly can be supported on the line card infrastructure as well. And just next system may support it. So then there will be easy to extend it. But the current system doesn't support it, so I see no way to do it right now, actually.
So, Giri, there was this question about, is the configuration stored in the driver and applied once the card is provisioned? Is that the expectation?
No, actually the provisioning is done. The driver configures the firmware, and the firmware is storing the configuration internally across the reboot, actually, or reset of the firmware. So when you do the provisioning of some particular slot and you reboot the system, the slot is still provisioned with the same type.
Taras, I hope that answered your question. Re-ask if you want to. Okay, perfect. Then I guess, Rupa, back to you.
Yeah, that's all, Rishi. Thanks for the presentation. I think we will have Moti from Marvell come on stage. Sujit, you may have to help here. I don't see the... Sujit?
Moti Nissim, right? Yeah, I see him. Moti, if you can hear me, yeah, there we go. He's here.
Hey, Moti.
Hi, guys.
Thanks for joining us today.
Okay, thank you very much.
It's a last moment thing.
Yes, so thank you for having me. So my name is Moti Nissim, and I'm here to give a brief update on what we are doing in Marvell for the Dent and switch dev. Let me see if you see my presentation.
Yes, we can see it.
Okay. Okay, so I'm part of the software architecture team working in Marvell. For those who are less familiar with Marvell, I will give a very quick intro. So Marvell is a data infrastructure company, and part of our portfolio includes high-end processors, storage controllers, networking devices, and security modules. I'm in person part of the networking BU, and my main focus is the Ethernet switches. We reinitiated the work in the switch dev a few years ago in order to enable users to seamlessly offload networking features into the Prestera switch devices and enjoy the acceleration. We were among the founding companies that started Dent in 2019, and we keep contributing to the technical and marketing committees. There are several platforms already available for the Dent with our SwitchDev drivers. I will present them in a minute. So currently under the Dent, you may find three major type of products, multi-gig and 10 gig, type of products with and without power over Ethernet. These current products are mainly for business use, but not only. We are actively working with ODMs to provide more types of platforms, smaller ones and more high-end. But these are the ones that are currently available. You can see them under the Dent. You can have them and download the DentOS in order to to have the networking offloading work. These are the major networking features that are currently available. Some of them are under work. What you see on the left side are all the features that we enabled and are currently available as part of DentOS 1.0. So we added support into the SwitchDev driver by Marvell for port configuration and statistics, lag, layer 2 bridging with VLANs, spanning tree, access list, and we leverage the TC Flower, IPv4 routing, ECMP, VRF, VRRP, and control plane policing. Soon to come is DentOS 2.0, and we are actually at the at the testing stage, validation stage, to make it available for the community. You will find additional features that we added into the SwitchDev, like the traffic policing for data path, data plan, port isolation, also known as PVLAN Edge, NAT, and we also introduced some enhancement to increase the scale by leveraging chain templates and multi-chain support. In addition, we also did some performance enhancement to make things work better. And we are currently working on the third release that will include IPv6 support for the routing, quality of service that covers VLAN tag, the user priority and DAI or CFI, and DSCP, traffic policing that will be done on the egress. We will provide a flexible way to have the control packets, management packets reach CPU. This will open, a way for user to have more control plane, user space application running without waiting for updates by Marvell for the SwitchDev driver. An example of such a user space application is .1x, the port-based access control protocol. We are also examining port security, which also include the MAC limit capability. Here I put a small asterisk to emphasize that there is some challenges that we see in regards to kernel support that we can discuss more, and we hope to work with the community to enable that. And last one is IGMP snooping. The ones that I marked with arrow that is facing up are the ones that are part of a formal kernel version. We have some of the features available in 5.6, some are added to the 5.10, and we keep enhancing the kernel support. And we are actively working on adding all of these features into a formal kernel release. More information you can find under the Marvell Prestera GitHub, the DentoS that I know was presented last year, and also the NetNext. This is what I had to present today. I hope that next year I will have much more, deeper dive into the features and capabilities, and having more colleagues from Marvell to share with me the discussions.
So, Mati, there's some questions. Here's one.
Okay, so what is the relationship between Dent and the kernel Prestera driver by PLVision? Okay, so probably some of you know that PLVision are also a part of the Dent community. They are actively contributing to the Dent. We work with PLVision to improve and extend our offering. And together with other companies, we hope to have the DentoS more complete and more accessible to users in parallel to advancing the SwitchDev driver.
That leads to the next question. So I think that the relationship is kind of hard to understand. Like what goes into, what do I not get if I roll my own Debian distro versus DentoS? What do I not get if I have the, what was the company called?
So basically what I listed in the previous slide, the major networking features, I'm not sure if you see it already. You see it now?
We see it.
Okay. So what we have upstreamed already is the ones that I marked with arrow, and all the rest are basically still work in progress from the upstreaming point of view. But all of them are available under the DentoS. Eventually, the DentoS includes, the Debian Linux distribution, our SwitchDev drivers, and more, drivers for the peripherals to enable the system. And the DentoS uses a more advanced driver by Marvell because it takes some time for us to finish the upstreaming process in the community while we get some, ask to have it available sooner in the DentoS. I hope it clarifies things better.
So yeah, to add to that, maybe, so DentOS is primarily driven by Amazon Go, right? And it has some SwitchDev drivers which are they're taking patches beyond as they are waiting to go upstream. So not all features are immediately available if you just download an upstream kernel. It also uses ONL. It collaborates with the OCP actually, and it's also collaborating with OCP on their Edge. OCP is the Open Compute Foundation, and on their Edge devices. Basically, it's an Edge OS.
Okay, so yeah, to add on top of that, and thank you, Rupa. So to add on top of that, and I see the comment from Donald about Sonic like. So Sonic is another open source, software NOS mainly for the data center. While DentoS, as Rupa said, is more aiming to the enterprise, campus, retailers kind of deployments. If you do like a zoom out, you may find Sonic running on more high-end devices and more expensive, if you wish, hardware. While DentoS is aiming for, other type of platforms.
I think that this conversation is actually more confusing than clarifying, right? So Sonic is a collection of SAI with a bunch of application level RPC interfaces that Microsoft uses for high scale development with a bunch of backend drivers that may or may not work with SwitchDev natively. Dent is, in theory, a much more native Linux distribution. So my question was very precise, which is, if I was a Debian developer, what do I not get? Why do I have to go look at Dent versus just taking Debian if everything below is standardized and normalized? And what I think I heard was, Dent is really a packaged, advanced version such that you can test it end-to-end, maybe focus it at the edge solution. But all of the things that are going into DentOS has the expectation that long-term, it will be upstream and will be available to every distribution out there.
Yes.
Is that fair?
Yes.
Okay. And I think that's the only part that matters, right? The devices and the scale and the scope and the table sizes, that will be very application and function oriented. But the net goal of SwitchDev, if you remember from the early days, was to build an ecosystem such that all solutions can draw from it, rather than very focused, vertically integrated stacks, which is what, when SwitchDev was started, that was the way everybody built everything, right?
Mm-hmm.
So I can maybe shed some light on what you can or cannot. What's the difference you can get with Dent and with I don't know, Fedora or whatever else you pick. In terms of Spectrum-based system, which uses MLXSW, you get the same driver. We always push everything first to upstream, and then just gets whatever is upstream. But still, I'm not sure you can run on every system. You can run the Fedora, which you can run Dent, because in Dent you have, for example, for some ARM-based system, you have platform support, which is currently not in upstream kernel. So that is something which is missing there. But from the perspective of MLXSW driver, we have everything upstream first. So there's no difference there. I'm not sure about Prestera.
Okay, so I think that worth saying that the Dent, if we separate Dent from DentOS, okay, so the Dent itself includes hardware that is tested together with DentOS. It includes the peripherals and system requirements to enable a deployable, robust systems, in production. And this is very much similar, probably, to Sonic.
The Dent and the OCP communities both they spend their time into that certification process, right? Like an OCP certified, and then there's a Linux Foundation which is hosting the Dent project, is also looking at having the Dent certification for certain hardware. So I think there was a related question from Jamal. Yes, it is an open, well-tested, not as in you can buy support from Dent, but you will get tested builds, right? Builds up an operating system, which can boot by ONE.
Shrijit, we can hear you typing. Sorry. One thing I want to emphasize, one crucial difference between DentOS and Sonic is that Dent is aiming to use the existing Linux kernel ecosystem with SwitchDev and all other things which are in upstream kernel. But Sonic is not doing that. Sonic is using some made-up abstraction called SAI, and which is backed by SDK binary drivers, and that is a very, very crucial difference. So in the end, eventually, then when it is not going to have any out-of-tree patches, it's basically going to be same as any other upstream kernel. Any other distribution, Linux distribution like Debian, Fedora, etc. So that is very, very different.
Actually, Jerry, it's even stronger than that, right? I mean, while SwitchDev API versus SAI is maybe a point that shows up, it's even more visible in the context of what an application sees. There is no netlink-like standardization that Sonic sort of adheres to. Sonic has its own, right? Whether it's good or bad, and whether it's the right scalable RPC model, I think is a different debate. The question is, do you get a layer that is repeatable? And whenever you say it's Dent or it's DentOS, it creates a new trademark or a new brand that gets difficult to understand the details of. So what was said recently, like most recently, which is it's really an all upstream but a better packaging solution. That sounds great, right? Because it makes it easy for people to experience the end-to-end stack. But as long as there aren't private pathways and things that say, oh, this is available in DentOS but not anywhere else, then things get potentially more problematic. And the reason why I say this is not because I have any dog in this race, but mostly because there are people for whom the distribution selection is already made. If you think of networking as a pure appliance business, which is the traditional model, it makes a lot of sense to go build an OS that is monolithic or well integrated. But if you're trying to sell into a data center or an infrastructure where the rest of the Linux bits is already pre-selected, then you want a Linux solution. You don't want a Dent solution or a Foobar branded solution, because that becomes another island, and then you don't get the value of integration, which SwitchDev is actually supposed to promote. That was my meta point. Andrew has something.
So this is a third point. Okay, when I need to explain, the difference between Sonic and Dent to others, in my company, usually I'm saying that for those who are more familiar and maybe like more the traditional networking boxes from the different OEMs that all of us know, they will feel more comfortable with Sonic, I believe. While if you are more like an IT or server person, you will feel much more comfortable with the Dent because of the native Linux support and tools that will probably ease the operation and the entire support around the network. Will make it to the server.
I think I would say that I'm not sure I 100% agree. I think there are people for whom large-scale software integration is important, for whom Sonic is a very interesting thing, because they get to basically build it like a software extension layer very quickly without they would argue that I don't want to know about Linux networking. I'm not I don't type IP route commands on a daily basis. I want an API, RPC type interface, and that's what I want. So I think it solves different problems for different people. Now, if the Sonic interface could run on top of SwitchDev, I think that becomes sort of the best case story, because then you can say infrastructure moves at its own speed, and software interfacing, daemon interfacing, status collecting, Yang, all of that runs at its own speed, and you can let them both innovate at their own speed. That's the way I would say.
Okay.
But, and Jamal is going, we already have that interface. Is it TC? Close.
Of course. Sorry.
Jamal, do you want a mic? Is that?
You on the floor, Jamal?
No. He's refusing to answer. Rupa, we should move along. I think we can keep time at the end for open discussions.
Yeah. Thanks a lot.
Okay.
And Moti, good job, by the way. I mean, it's really good to see a large collection of SwitchDev drivers. It's good.
Thank you, and I hope to share more of our work in the next event, and maybe before that.
By the way, I mean, before we move on, I'm waiting for the consumer grade SwitchDev device that I don't have to write a PO for. So when that happens, please let me know.
Yeah, in the Dent meetings, somebody brought that up. Somebody wanted to port Dent to a Realtek device. I think, Shujit, you might remember long ago.
Oh yeah. So yeah. If it's a sub $200 device, please include my email in the announcement.
Cool. Okay. The next is Alexander. Alex, we will try to get you back. Actually, Shujit is going to try to get you backstage.
Hello, my name is Alexander Zubkov, and I work at Curator Labs, and we use SwitchDev-based switches in production. It is Mellanox switches. So I want to share my experience with configuring the switches, so like operations side. So as I know, there are like two categories of SwitchDev-based devices. It's the one category is small devices like CPEs or some embedded devices, and I'll call it CPEs during that presentation. And the other category is high throughput switches with interfaces like 100 gigabits. Like top of the rack switches and spine switches, and I'll call them Tor switches during this presentation. And the second category is our case. Our main service is DDoS mitigation, and so we deal with high bandwidth links, and we use such switches as a core switches at our point of presence, and they can interconnect our filtering nodes, uplinks, and clients, for example. So my experience is biased to that category, and this is important because, as I understand from my point of view, when you deal with CPE switches, it is okay to have like one-time configuration that you implement on startup of the switch, and if you need to change something, it is okay to reboot the switch and to apply configuration again. But when you work with high bandwidth switch, it is usual that it runs in production, and it is it is not welcome if you need to change something to reboot the whole switch. So the big difference is that you need to make some changes to your network configuration in runtime. And so why SwitchDev is good for us? SwitchDev is in vanilla kernel, so you actually can use any Linux distribution that you want. Like it was said here, if you like use some standard distribution in your company, it is preferable to use the same distribution on the switch, so to keep the same automation tools or standards in your company and so on. So it is great, and in case of Mellanox switches, they have their driver in the main kernel tree, so there is no problem to use any distro that we want. And of course, we can use in that case various tools and APIs in Linux that are already there, and software like routing daemons, monitoring tools, automation tools, and so on. And the great part of that is that you get all that for free. For example, if you use some vendor's environment or system, for like EOS, iOS, and so on, you need to buy subscription to update your system, or if there are some security issues, you need to wait when the vendor produces the update and when you can download it and so on. But with the Linux system, you get it right there when the patch is ready. You can apply it by yourself, or it is also gets very quick into distributions. And that all features are so great that it is worth the effort to use SwitchDev, no matter that I say next in my presentation. So, but there are a bad part of it because you do not have like the shell of the vendor. You need to during your operations, you need to configure the switch with standard Linux tools, and so you need to, when you configure interface and routing, you need to configure things like port splitting, bonding, VLANs, VIFs, and you do not have like some single tool that will do that for you in declarative and that have declarative configuration. You have like a bunch of IP route commands and devlink and others, and you need to put that by yourself to get the config. And also you need to reconfigure the running switch, and so you need to also to run those commands to see its output and to understand what the current state of your switch is and what changes you need to make to have the desired configuration. I draw here like this is an outline of your SwitchDev configuration. This structure is like a house of cards. If you touch it inaccurately, you can ruin it easily. So it may be very hard sometimes to introduce some changes. So we need some tools that will help us to do that all. And from my perspective, what I want from such tool is first, it of course should support all the features I need, like port splitting, bonds, VLANs, VIFs, IP version 4 and 6, of course, and black hole and ECMP roads. I want it to have human readable configuration, and of course I want it to be able to apply the changes during the switch runtime. And I want that to course to reduce mistakes, for example, by having a simple configuration and doing some black magic inside by itself. Also, I would like it to be stateless. I mean that it doesn't keep some custom state of what it thinks the state of the switch is. And for example, if you introduce some changes manually after the tool is run, like change IP address or make interface up or down or something like that, that when you run the tool the next time, that it should look at the actual configuration of the switch and introduce changes needed for that, and not for the state it thinks it is. And it would be great that if tool can show the current configuration of the switch in its own configuration format, so I can store it as a startup configuration or some additional configuration. And I also want to be able to keep management interface configurations separate. So I can, for example, configure it independently during the switch's startup with some operating system configuration, and this tool should not meddle with it, because management is very important. And I don't want, and some tools want to configure all interfaces in the system. Here is an example config. I will structure of interfaces. I will show some examples that implement this configuration. So the first option we have is bash script, of course. We can here you can see an example. It creates needed interfaces, links them, then it assigns VLANs, brings interfaces up, and adds IP addresses. So you can have such startup initialization script written in Bash. You can use you can write it by hand, generate it with some templates or tools like NetPen IO, and of course you in such case you run commands by yourself and you can do everything you want. So there is no limit with features it supports, and if you format your script well, it can be even readable. But the main problem, as I said, you need to reconfigure to implement changes by hand, and you need to look at the current state of the switch, and you need to know which commands you should to put to change your state. And it is hard also because there are some restrictions. You for example cannot assign a master to interface when that new master interface also has master. So there are some restrictions, and you need to keep that in mind when you do the changes, and so it can lead to human mistakes and different problems. And also, if you want to keep the current state, you need to understand it by yourself and to write that by hand, for example. The next variants are different if up-down configurations. For example, here you can see configuration for if up-down NG. You can see here is bond and ports defined. The next screen, switch and VLAN and VIF defined. Here is how the configuration looks like for if up-down NG, and at least for my configuration that I showed, all the features are supported out of the box by this tool. And if something is missing, you can extend it with modules or add custom commands. And the configuration is more readable than Bash script, but I think there are also drawbacks because there are extra words or extra options you should to add, which maybe which is better to not to show them and to have some same defaults maybe. But this tool have a big problem that at first it saves its custom state, and if you change something, it do not notice it and do not use it. And also it cannot introduce changes. If you change the configuration, it doesn't remember the previous configuration and doesn't look at the current switch configuration. And so when you make some changes, it do that badly, so you actually cannot use it in such situations. And also it cannot show the running configuration. The next one is if up-down 2. The configuration looks almost the same as if up-down NG, with maybe minor changes. It also can be extended with modules. You can add custom commands, but it is different in that this tool is stateless, and it can really do some great work when you want to do some changes. If you try to load new configuration, it notices how your switch is really configured now and applies the needed changes. It also can show you the configuration. So So this tool fulfills most of the requirements I have. It is it is not surprise because this tool is written by Cumulus, and they should have similar requirements from their users. And the next one tool is MLX Toolkit. It is our in-house tool that we open sourced. And you can see the configuration is much smaller here. And that is because it is much simpler tool. It is made for a very specific case that we use, but in its own domain, it works quite well for us. For example, you will not find such feature like port splitting in many other tools to configure Linux networking, and we implemented that in our tool. And it also implements changes to the running config. It understands what it needs to change in the current configuration. And I think the configuration of this tool is much easier to read because we made this works with its own model, and the defaults are strictly defined there. So you do not need to configure that by hand, and so the configuration is like have less lines. And it is open source, and you can use it.
Quick question. So does it support all the DevLink options, splitting and?
It is used DevLink for splitting only, and I do not think. What other options you think
shared
about?
buffer config and all that? And I'm curious why it's called Mellanox. I mean, does it work on other switched systems as well, or?
I call that it MLX Toolkit because we use it on Mellanox, but I think it can be adapted to other switchdev based devices. There was no use case for us, at least, and nobody asked to do that.
Yeah.
Okay. The next interesting tool is NMState. It has it uses declarative YAML configuration of Linux network, and but it uses a network manager at its backend. So I'm not sure that it can do like smart things when reconfiguring the interfaces. I suppose if it just makes all the affected interfaces down and then brings it up, so it may disturb your system a lot. And on top of that, it doesn't support VIF and VLAN aware bridge, so I did not make a configuration for that, example configuration. But the tool is interesting, and what they do looks promising.
There's a question about systemd network D. Is it coming in the next slides, or have you tried systemd network?
Yes, I have. I will have a couple of words about it. There is also native ID from OpenWRT project. They made a redesign of their networking some time ago, and they say that this tool can do changes in a smart way also, but they have almost no documentation, and it's hard to understand what are capabilities of this tool. And it is tied to OpenWRT infrastructure, so you need to put other OpenWRT components if you need to use it, like UBus, UC, and others maybe. And it also runs as a daemon, so like if you want something that like one shot, that it is not the option. It is also that doesn't have VIF support and we are breaching for now, at least. And at least I did not found how to configure it because of lack of documentation. But the things looks interesting too, and maybe if they look at some point at not only to CPE devices but for like Tor devices also, maybe something good will grow from that. And there are some other tools like systemd, networkd, and OSNetConfig. I did not like research them much. I think systemd, networkd is not smart also when introducing changes. I think, but I don't know. Maybe they do like it better. And there are OpenStack to OSNetConfig. They also have declarative configuration of networking and have support many features like bridges, bonding, and so on. But they use as I understand, if up-down scripts as their backend, so they have some limitations from it. And if this is the most interesting tools I know. So if you like want to configure switchdev based switch and looking from what to start, you can use this list. And if anybody knows something more interesting that I did not found, I ask you to write me in email. And maybe we have some interesting conversation. And let's return to requirements, because that was like basic requirements. So, but I want actually more from switchdev and from such tools. For example, it will be good to have to make some atomic changes. So we like prepare a new configuration to put it to the tool, and so we like have it change fast. But it of course requires support and kernel and IPs for it. And then maybe some tools will be there. And also what will be good to have now is I want to use, for example, automation tools with my switches to reconfigure them with such tools. So I need maybe something like Ansible plugins or netconf yarn support for these tools. And for netconf yarn, for example, I looked and I found two notices. One is some project at OpenWRT, but I look this project consists of of several tools, and I looked at some of them have commits several years ago, but others more active, so I don't know what is actual status of this project. But maybe it is like working now and you can use it. But it is OpenWRT, so you have the limitations that I described. And on at the documentation page of the nmstate, I also saw some notice of and picture of netconf and yarn, but I did not found anything else there. So I think it's like only a concept. So at least as I didn't found more in the internet regarding netconf and yarn, so I think there is like more. There is a way to like for improvements in current toolkits. I also ran a poll before this talk. There were a few answers, 12 people, including me. So thank you everybody who participated in it. There are a few answers. I just put it all there. The first part of answers here, I split it by the operating system used to two categories, Tor devices and CPS devices, but it's only my guess. And as I see here, when there is a little data, but as I see, when the fleet of switches is small, people use bash scripts, and but as you can see, they are not quite happy with them, and with it. And I think it is because of manual changes you need to do by hand, and when the fleet grows, people turn to some more advanced or proprietary tools, develop their own tools, and sometimes they became happier. But mostly, people do not like what they have. At least with open source tools that are available, and for the CPE tools, you can see that there are answers. There are bash, if up down, and easy, and people are quite happy with that. I think it is because of less requirements, and so it is easier to make them happy in that case. So what we have so far, there are several tools out there, but only once of them can do some very good job, and even though those have their drawbacks, and there is a way to improve them, like support automation and so on. And if you did not find something suitable, and if you made in-house tool like we did, so I ask you why you not open source it. Maybe somebody suffer without your tool, so don't be shy. But all that I said, it's only one part of the story. On Mellanoxes, if I want to do access control lists, I need to use TC filters on physical interfaces, and I also need tools for that, and I have all the same requirements for tools to help this activity, to help me with this activity. And I do not know of any tools for that, and not saying about my requirements. Of course, you can use bash script. Here you can see the example how you can configure it, the various changes. And if you want to make changes after you configure it, here is an example of TC filter show. There was 12 lines to configure the filter, but here you can see only two filter rules here on one screen, and so you have such a long wall of text on your screen. It totals 114 lines, so it's almost 10 times bigger than your config, and I find it very hard to read and interpret that. So I think such configuration is write-only, and it's almost impossible to. It's possible, but you need to put a lot of effort to introduce some changes. So if you need to change it, that I wish you good luck. But of course we have support in our tool for that. And here you can see the same configuration that our tool uses. But it also made for our specific case. It uses its own ACL model, and so it can configure and show current configuration only when it conforms to that model. but the great is that it's also stateless, and it can apply changes, and it is very handy for us. And this tool, actually, I wrote it in the first place because dealing with those TC filters was very hard, and maybe if I did not need that, maybe the second part of the tool that configures interfaces would not appear, because maybe I would found if up down 2, and we'll be happy with that things. So it looked good for us, and so it was not that hard to write. So the second one for interfaces, and considering its ACL model, a couple of words. It uses one shared ACL on all ports in TC. It is called block, and it have a single chain per each VLAN configured, and you can also have auxiliary chains, and so it have main chain where it matches VLANs and jumps to corresponding chains. So it based on VLANs, we use it like that, filters. So that's all I wanted to talk today about. So thank you very much. And if you have some questions, I will be glad to answer.
Yeah, thanks, Alex. I think the operational problems are, understood, not problems. There are solutions. There is IFFW too. But then, like we talked previously, right? If only there was one single company that put out an API, and yeah, Sonic has that API, but that API is also a bit fragmented as far as I.
Yes, it is. There are some like systems like Sonic that may have better toolkits for configuring the switch, but like if you want to use switch dev, you like limit it with that.
There is a question: does anybody use a switch dev with a non-typical switch devices? For example, OVS offload on NIC and virtual functions.
Yeah, so we actually support it on NICs, but there's define what actually switch dev is. So what we have on NICs, we expose the embedded switch, so you will see, for example, for each virtual function, you will see a representer net device, and you can do all sorts of stuff with that. You can attach TC rules on top of that, etc. So basically, there is a so-called switch dev model on the SRIOV NIC.
And they use DevLink, right? DevLink was extended to support.
Yeah, for the configuration of the ports and the parameters of the VF, etc. But you can just use TCE to do the redirection of the packets and filtering and stuff. And actually, we are in a process at least I think we are of implementing the bridge offload on SRIOV device as well.
I think it's already in.
Yeah. Maybe.
Yeah, and yeah, Nick person was supposed to come to this talk to just talk about how they use the switch dev API or DevLink and so on, but the timing and there was a conflict, so they couldn't make it. Yeah, and there was a comment that switch dev is also used in DSA. Yes, there's a lot of DSA drivers, and they also couldn't make the time today, but hopefully next time. Andrew should be in the crowd, who does review a lot of, who is a contributor to DSA and does review a lot of DSA patches.
So I would like to react on the presentation. I think that the biggest problem is that the Linux kernel model is very wide, and you can do all sorts of use cases there. So that it's not really easy to find one tool which rules them all. I mean, if someone has a tool like you have in a different company with different use cases, it will certainly use different interfaces. So I think that we can find some common things which are needed to be done always. Like, for example, the configuration of Devlink splitter ports or Devlink resources and stuff like that, which may be done in, as I said earlier, the systemd, Devlink D, or something like that. And so we can perhaps divide some configuration items into different daemons or configuration tools, but I don't think you can find one thing that will sort it for you.
Yeah, of course. but that is like the point, that you need to have like a set of tools and to choose from.
And I think most of the tools that are being developed on the server side, right? All those you mentioned, systemd, networkd, and all that. Networkd is being used by some switch dev people, but some of them don't really support the new WRF option or new VXLAN options. So there is always that gap, like Jiri mentioned, which we should try to close. Any questions we're missing? So, sorry.
No, there was one, but it looks like Ido is on it already, which is how many rules does the device support?
The MLX5?
Yeah, it's a little interesting question. So this is a NIC question or a switch question, or because switch dev doesn't care, obviously.
It's a NIC question. Well, I've been looking at NICs as well. So the recent number that I know was, 8 million. I don't know what. It depends again. It's a flat flow table. That's the number of entries. I don't know how that translates. Yeah, Ido is answering that question. So I had a quick question. If anybody has tried NetPlan NetPlan internally uses Network Manager or systemd networkd, right? But it has a kind of YAML-ish config API.
Yes, but I think maybe I didn't look deep into that. But if it uses like something as a backend, it has the limitations of the backend.
Any other questions? This was our last talk, so any other questions or any other topics people want to bring up? Okay, Jamal says 8 million. You can go higher than 8 million. Jamal, you probably have the right number. 12 million?
I mean, this is an easy way to fill up the next 20 minutes that we have left. Just say no.
Jamal needs to answer the TC question. The TC. Is there a TC API? There was a next generation TC, right? It's still an IP router, I think. I don't know if anybody maintains that. At some point, I wanted it too.
There is a question. Are there any problems with the latency of adding rules via TC and driver?
Well, what is latency in terms of like how many rules you can put in a second, or?
Yeah, I guess. Mikhail, do you want me to give you a mic? Might be easier. Yeah, there you go. Oh, no, that's Jamal. Mikhail, if you raise your hand, I can get you the mic, but Jamal got there first. There we go.
Hey, you can hear me?
Yes.
Actually, there's a paper on this topic by Marcelo and Vlad Buslov from NVIDIA, which, I'm sorry, I'm answering Mikhail's question.
I think I can close the presentation.
All right, so there is he asked what were the latency of accessing of adding the rules. I think the numbers I've seen are in the hundreds of thousands per second. You can add 100,000 TC rules or more.
But is that a switch dev thing? Is that a TC?
No,
thing?
it's a TC on Mellanox. I think it's Connect X D6.
This is offload. TC offload.
Yeah, offloading. Yes.
Makes sense. Okay, Mikhail has a question, so I'm going to. Jamal, are you done?
Yeah, sure. I just wanted to say that.
Okay.
Oh, you can bring only one person at a time?
Yes.
Hi.
Hello.
I think for all my question. As introduction, we trying to implement this type of switch dev that Jiri mentioned in Mellanox 5, that trying to create this port representer and do this TC offload. Yeah, and I just wondering how many rules we should support, and also how many type of rules we should support, because on our hardware this is highly limited resources.
Yeah, well, it depends on your implementation actually, and how do you. Well, like you can use the chain templates, for example, which would give a hint to the driver which kind of rules are going to be added by the user, so you can manage the resources more efficiently. But that's what we do in MLXSW, because we can have rules which takes one place in the TCAM, but we can have other rules which can take like 2 places, basically. So by the chain template, the user can tell that only like some small rules are going to be added, and the TCAM is going to be utilized better. So we can do something like that. Basically, the infrastructure is out there. So it's up to your implementation inside the driver, I guess.
Yeah, thanks. Yeah, we have similar solution for this TCAM. Okay, thank you very much. Great presentation.
Thanks. Any other questions?
Okay, I'm not seeing any more questions. Jamal, any more? Even Jamal's done, so there must be no more questions.
Long day. Okay, thanks everyone. Thanks for this. Thanks for the speakers. And thanks for the audience. And thanks, Shuji, for hanging around. Bye.
Thank you. Bye.
Thank you, Rupa. Thank you, Jiri. Thank you, Alex.